Okay. Can you all see the screen? Can I see the screen?
Yes, sir.
Okay. I'll share some questions, 2 questions today. We will complete those questions and then by that we'll wind up the problems in Pelton rectifying. The same question I shared in the WhatsApp group also. You can copy from that. Hmm? Are you getting the question in WhatsApp group? Did you got that?
No, sir, it's not.
Okay. But meanwhile, you please copy that. I don't know. I think there is an internet issue. You copy the question. A double overhung Pelton wheel.
Yes, sir. Now it came.
It came, huh?
Yes, sir. 2 questions.
Okay, okay. You copy that question. A double overhung. Yeah. Can you see? Next.
Sir, jet velocity coefficient is 0.97 or 0.91?
0.97.
Okay, sir.
Okay. See, almost most of the problems, what they used to do is the core of the problem will remain same. Same, either power output, efficiency, those things they'll ask. But the only thing what they'll do is the initial steps. Initial steps, they will ask you in different way. That you should know how to crack it. If you know that, you can solve all kind of problems. Okay. So here also, further problem, as what he is asking you to find out, determine the size of the jet, that is small d, mean diameter of the runner, that is d, specific speed of each Pelton wheel, that is ns, he is asking, correct? So you know how to solve what is the formula for small d, what is the formula for capital D, what is the formula for specific speed, everything you know. But to start with, he has done something extra here. He has added something extra, that is a double overhung Pelton wheel. See here, till now what you studied is only a one Pelton wheel with number of jets. But here he has included two Pelton wheel turbines. He has included number of Pelton wheel itself is 2, not the jets. If it is jets, you know how to solve. If number of jets are 2, 3, 4, 5, you know how to solve. But if there are 2 turbines or 3 turbines, how to solve? You don't know. We'll solve that. Okay, we'll solve step by step. Okay, we'll go for the solution. Can you see the screen? Hello?
Yes, sir.
Okay, fine. Here what is done, a double overhung Pelton wheel turbine. You know what you mean by overhanging, correct? In SOM, in mechanics of materials you studied, what do you mean by the overhanging? That means something it is supported at one end and other end it is left free. That is the meaning of overhanging. So here a double overhanging Pelton wheel unit is operating at 30 megawatts generator under an effective head of 30 meters. That means what he has given, power generator. So this is a new word for you. This power generator is 30 megawatts he has given. So that will convert into kilowatts. 30 into 10 to the power of 3 kilowatts. This is what we require. Whatever the unit he has given, convert into kilowatts. Under an effective head of H. Effective is nothing but the net head is 300 meters. At the base of the nozzle, determine the size of the jet. Small d. Small d is nothing but the size of the jet. Mean diameter of the rotor is capital D. And then speed, specific speed, ns is equal to how much? Assuming the generator efficiency of generator. See, this is also new word. Generator efficiency you not come across. This is 93%. Pelton wheel efficiency, that is efficiency of blade, is equal to how much? Or it is also called as efficiency of hydraulic, efficiency of turbine, all are same, 85%. The speed ratio, 0.46. Jet velocity, CV. And the jet ratio, GR. Jet ratio is how much he has given? 12. Number of jets, small n, is equal to 1. So this is the concept, this is the data he has given. So for this, let us first draw the diagram for that. So assume that this is a generator. So this concept is called overhanging, and here we are having a turbine. This is turbine, and the output shaft is here. Means the inlet will come here. It will rotate. Because of the rotation, this shaft will give the power to the generator. Similarly, double overhang. No? So I'll use one more shaft, one more turbine at the other side. So we'll call it as T1, turbine 1 and turbine 2. So for this, the fluid will come and hit here from this direction. Then the power will go for this and it will go for this generator. The power will be taken by the generator. This is the arrangement. If it is 3, what will do? We'll increase one more. If it is 4, we'll increase one more, like that. There are some problems he has asked 3, 4 based on the, you can see our earlier question. Similar question with 3 generator, 3 overhanging turbines. Similar concept. So this is the figure for overhanging, and where the power is transmitted to single generator, which is at the center. Okay. Now, so here what we are going to get is So what is the general efficiency formula? Efficiency formula for anything it may be, it is output by input. Correct? So what is the output from this entire arrangement? You can see efficiency of the generator, if I take, that is power generator is output divided by power input to the generator. So it is nothing but P generator by P of turbine. Will you agree with this? That means the generator, what it is going to get, means what is the power output from the generator is PG, and input for the power generator is the output from the turbine. This itself is the input, no? So that, are you getting?
Yes, sir.
Okay. So I can write like that. So from this equation, we know generator efficiency, we know power generated from the generator. So can you find out what is the power input for the generator? The power input for the generator is nothing but a power output from the turbine. Oh, I'll write like this. Power output from turbine. This itself is considered as power input for the generator, right? So here I can take out power from turbine is equal to power by generator divided by efficiency of the generator. So power by generator is 30 into 10 to the power of 3 divided by efficiency of the generator is 93. So that I'll take 0.93. So what is the power by turbine? So what is the power going out from the turbines? There are two turbines here. So that this power from the turbine is from combining of those two turbines. How much power is going to generate? Anyone? So you want the answers?
32,250.
30?
32,000.
Sorry. Okay. 32,000?
5,800.
5?
32258.
328?
32258.
Sorry. 32258 kilowatts. So this is the total power generating from both the turbines. So we want to solve all the derivation, means entire formula is based on only one turbine. So that power from one turbine is how much? This is P turbine divided by, there are two Horan turbines, so that I'll use 2. So it will be equal to 16.125 kilowatts. Sorry, into 10 to the power of 3 kilowatts. Correct? So this is the power output from one turbine. If you know how to take this power output from the given data, further procedure is same. If you know how to take this power output from one turbine, further procedure remains the same as we did in the previous problems. Okay. So what he is asking to find out? D, small d, capital D, and S. Okay. We'll find out the Q first. For finding the capital D, we want Q. So what I do? P from one turbine, formula is equal to rho Q G H efficiency by 1000. You know this formula. So Q from one turbine is equal to P into 1000 divided by rho G H efficiency. So P is 16.125 into 10 to the power of 3 into 1000 divided by 1000 into 9.81 into H is 300. Efficiency of the turbine is 0.85. So can you tell how much it is? What is the Q from one turbine? So total discharge for one turbine.
6.45.
6.45. See, once you know Q, further proceeding, what is the next step? Our intention is to find out small d, capital D, and ns. Okay. We know the speed ratio. So with the help of speed ratio, also I can do that is capital U is equal to speed ratio into square root of 2gh. So you know speed ratio. U I can find out easily. 0.46 square root of 2, 9.81 into h is 300. So what is the value of U in meters per second?
35.29.
Huh?
35.29.
35.29 meters per second. That is the U value. Once the U is finished, we'll go for next sheet. So if U is known, how to find out D? You know the formula, no? So the formula for U is equal to pi d n by 60. So this is one formula. Whether I can use this formula right now? Whether I can use this formula right now? So from this I can find out D. It is impossible because I cannot use, because n is not given. If n is given, I would have solved this and I would have taken D. Now what I'll do, I'll go with one more method. Q from one turbine is equal to area into velocity. So that is n into pi by 4 into d square into V1. So this is Q from one turbine. So in support of this, we want V1, right? V1 is equal to CV square root of 2GH. We know this. So V1 is equal to, what is CV? CV is equal to 0.97. H is 300. So what you will get V1? You will get in terms of meters per second. So use this V1 here. And take out diameter of the jet is equal to diameter of jet. Q into 4 to 5 meters. Use this equation here. Once you get V1 from there, use this equation. What's the answer? First you tell V1. Anyone tell V1?
74.42.
Yes, 74.42 meters square is the V1. And what is the diameter of the jet? So I have not used this. You should know what is the reason I have not used. If n is given, I would have done that. Then I can easily proceed. I would have easily proceeded. What is D? Small d. Q total we got no previous page. Huh? 6.45 into 4. Number of jets is 1. So V1 square. V1 you got here. So what is D? Shall I write answer?
0.33.
Yeah, 0.33 meters. So once you know that, we know that we're having formula for jet ratio. What is the formula for jet ratio? Capital D by small d. And the value of these two is given in the question. That is, it is 12. Once you know the small d, you can take out capital D like this easy. Meters. How much you get? See, is this
3.98.
huh? 3.98.
98.
Okay, 98. So let us keep it decimals only. Don't round off. Let us keep in decimals only because this is a meters. This is not numbers, so no need to round off. Let it be in decimals only. If round off also no issue because it is very near to 4. You can take as 4, but let it be as it is. I will not change this. Done. So in the previous page, what is unknown now? So diameter of jet is finished. Diameter of rotor is finished. Now we'll go for specific speed of the turbine. So what is the specific speed formula? Remember that we did in the first chapter. Specific speed, there are two specific speeds. One is for power absorbing machines and one is for power generating machines. What is the specific speed for power absorbing machines? Oh, sorry, power generating machines. NS is equal to
N2 P by H bar 5 by 4.
very good. H to the power of 5 by 4. I think probably you remember this formula I stressed a lot because this will come in every chapter. See, even though we have not done anything about the specific speed here, we are using this formula. That means the first chapter is very much essential for all the modules. All the modules are all the chapters. So you prepare well for the first module. That formula I am taking here. Hence, he is asking a specific speed. So here, what is known with us? N is unknown. N is required. P is known. H is known. So I'll write the other side to find out N what we did. What can anyone tell what we are supposed to do to find N?
We can use U is equals to pi d n by 60, sir.
Very good. You can use U is equal to pi d n by 60, but you want U there, correct? U is also finished, right? So U is equal to pi d n by 60. U is finished. In the previous sheet only we did that. So the value of U is 35.29. With the help of that, you can find out N. U into 60 by pi d. So what is the value of U? We got 35.29. 35.29 into 60 by pi into capital D, we got 3.98. So what is the value of N in RPM?
169.34 RPM.
169.34 RPM. Use this over here. If I use that, then definitely will get the specific speed of each turbine. NS is equal to 169.34 root of. See what power you use, whether you use power of generator or power of turbine.
Turbines.
Very good. Power of that too. In that there are two powers. This is power of turbine for 2 turbines, and this is for 1 turbine. We have to use always for 1 turbine. 16.12 into 10 to the power of 3 divided by 300 to the power of 5 by. So the specific speed, there is no unit for this. If you want to write, you write as SI units. Or if you want to write, sorry. So here, root of 16.12 into 10 to the power of 3 divided by 300 to the power of 5 by 4. So that will get NS is equal to, write in SI units. Or if you want to write that in RPM, put that RPM in box, in a bracket. So what is specific speed?
P note 6.27.
Cross check once again. 306, sir. Got different answer. Others?
$17.18.
17.18 SI units. Or inside the bracket, you can write as RPM. So this is how to solve the problem. Whenever the power double O-run turbines are given, or O-run turbines generally. See, the problems will be very simple in the further steps. Only you should know how to take the data and reach in a known manner. Means all the data, whatever he has given, you have to convert in the form whatever you know. Like that, you have to convert. If it is done, I'll go for the next problem. And I'll wind up this Pelton chapter. all the types of problems I covered. You go through the earlier question papers. If you're having any doubt in any of the question, you bring that, we will solve in the class. Okay. Now we'll go for one more problem. I'll project the screen. You copy that question. The same question is there in the WhatsApp group also. Can you see that question in a WhatsApp group? You copy from that, or else I'll read the question. Okay, you copy the question. Show that the specific speed of a Pelton wheel. Show that the specific speed of a Pelton wheel is given by, yeah, you can see here. Now it is projected. Can you see?
Yes, sir.
Copy that. It's done.
Yes, sir.
Okay. So here, I think probably you can do this. You try by doing yourself a bit at least. We'll see how best you can do. Everything is given here. A specific speed formula you know for the pattern, but he don't want that in that form. He want the specific speed in this form. Ns is equal to 240 root of n by n. M by m. What is n? The number of jets. M is wheel diameter to jet diameter. That is, what is the general formula? What we are taking wheel diameter to jet diameter? We are taking in terms of JR. So he is given in terms of m. That's all. So assume the jet velocity coefficient is 0.97, speed ratio is 0.45, efficiency of the turbine is 0.89. So we want in this form. Or you can also ask like this. ns is equal to 206 root of n by m. If I use P in kilowatts, I'll get in this form. If I use P in HP, I'll get in this form. Both are same question. Both are the same question, but he has not included this word. I included here at the bottom. So I will get ns in this form if I use P in HP. If I use the power developed in kilowatt, I'll get in this form. You try to obtain, you know how to convert HP into kilowatt, right? So just if you multiply, this value will change, 206 to 240, that's all. But the remaining procedure for converting this specific speed to the standard form to this form is same. We'll see how best or who can do first. If anybody done, you please project the screen. So shall I show the initial steps how to proceed? I'll write down the data and then I'll show you the initial steps how to proceed. You try proceeding that. We'll see. See, we know P is equal to rho Q G H efficiency by 1000. This is in terms of kilowatts we'll get. We'll get in terms of kilowatts. So he has given ns is equal to 240 root of n by m. And ns is equal to 206 root of n by m. So if this is if I use P in kilowatts, I'll get this. If I use P in HP, I'll get this. See, in all the problems or the simplification procedure, you know, if the power is given in kilowatts, how to solve, we know. So what I'll do, first I'll solve this problem. First I'll say I'll solve this because power I know in kilowatts. If I use power in kilowatts, ns I supposed to get in this form. I'll do that first. Then conversion factor, by using a conversion factor from power kilowatts to HP, I'll go for that. What is the conversion factor? I'll write that also. P in kilowatts. To convert that, P in kilowatts, just you multiply with 1.34 so that you get in P in HP. So either you can start directly solving P in HP or directly first solving P in kilowatts, then converting to HP. Both are correct. Any one method you can adopt. But this is the conversion of kilowatts to HP. Okay. So I'll give some hint how to solve. We'll see anybody is going to solve. Anybody got the answer. So we got the P. So what is the Q formula in this? We got the P. Q formula in this is N into pi by 4 into D square into V1. So this we know. And V1 is CV square root of 2GH. That we know. And the standard NS formula. This is important for me. NS is equal to N root P H to the power of 5 by 4. So this is important step in this. Means he is expecting this one to be in the form of 206 into root n by m. So how to convert this? You solve in any method, but try to obtain this form. Here he has given m is equal to small d by capital D by small d. Means as per ours it is jet ratio. He has given another way. M is a jet ratio. He has given capital D by small d. And data, what all the data he has given? Speed ratio is equal to 0.45, and then overall efficiency is equal to 0.89. Then what else again? Sorry, it is turbine or overall, anyone. CV is equal to 0.97. So these are all the formulas he has given. So with this formula, you proceed further. I'll give U is equal to pi dn by 60, or it is also called as speed ratio into 2 root of 2gh. Using all these equations, I can easily obtain the specific speed in terms of 206 root n by m. If anybody is done, please let me know. Okay. Meanwhile, I take the attendance. I'll take the attendance now. If anybody is done, let me know. So I'll ask you to project your screen. Answer the attendance. Sai Sumant,
Present, sir.
Abhishek. Abhishek. Abhishek Narayana. Adarsh. Ajay.
Yes, sir.
Akram.
Present, sir.
Akshay. Alap.
Present, sir.
Ankit.
Present, sir.
Ashutosh.
Present, sir.
Vivan. Chinmay.
Present, sir.
Chandan. Charishma.
Present, sir.
Darshan.
Present, sir.
Ibad.
Present, sir.
Govind Raju. Pura Jayant.
Present, sir.
Purushottam.
Present, sir.
Pratiksha.
Yes, sir.
Jayant.
Present, sir.
Jitin.
Yes, sir.
Chaitanya. Karamjit. Okay. Kartikeya.
Present, sir.
Kiran. Mustamala. Maizin. Sharan. Narendra. Narendra. Nihal.
Yes, sir.
Nikhil. Nimala Varmesh.
Yes, sir.
Nitin. Rajbal.
Sir.
Prince. Princhan.
Sir, yes. Prayag.
Prayag is present.
Yes, sir.
Prince Prabhakar. Princhan.
Yes, sir.
Rakshit.
Yes, sir.
Rishi.
Present, sir.
Sandeep. Sanjay.
Yes, sir.
Sanjay N.
Yes, sir.
Satish.
Yes, sir.
Saurabh.
Yes, sir.
Shivam. Shivam Kumar. Shivam Sundriyal.
Yes, sir.
Shivam Chavan.
Yes, sir. Present.
Srinidhi. Siddharth. Siddharth R. Sudeep. Sunil. Tarun.
Yes, sir.
Vinay.
Yes, sir.
Vipin. Vivek.
Yes, sir.
Milan. Pranelal.
Present, sir.
Saksham Singh. Akshat. Akshat.
Present, sir.
Chaitanya.
Yes, sir.
Mahesh. Nishant. Ramesh. Shashank. Sautrik.
Present, sir.
Srivatsan.
Present, sir.
Madan Kumar. Manu. Ganesh. Ganesh. Shadab Khan. Suman Xavier. Vijay. Vijay Kumar. Zahir. Rishi. Mahimaraj. Okay. Anybody got the answers? Anyone got the answer? Okay. If not, I'll explain how to solve this. Okay. So here, how to solve is you go on substituting one value in other one. Means, for example, because no data are somewhat insufficient. So what you're supposed to do, you express one thing in with respect to others, so that you can easily solve the problem. So how to go for that? I'll take a P. P is equal to rho. Rho is nothing but 1,000. Q total. Q is nothing but n pi by 4 small d square into V1. V1 we know as CV into root of 2GH. Okay. Into overall efficiency divided by 1,000. You simplify this. This and this will get cancelled off. Then small d, whether is given, small d square pi by 4 GB. Okay, we'll simplify this first. P is equal to what is number of jets? He has taken number of jets as 1. He has not given anything, no? So we'll take as 1. Nothing is given, so we'll take n as it is, because in the derivation finally we want in form of n. N into pi by 4. D square is also unknown, so we'll keep that as it is. Into CV is known. What is CV? 0.97 root of 2 into 9.81. Whether H is known? No, H is not known. So I'll take out separately. Root of H. Into efficiency is 0.89 divided by, sorry, nothing is there. So if you simplify, what you will get, can you tell? Rho Q. This is of Q, no? Oh, here I forgot G into H. So it is 9.81 into H is. So you unknown terms, keep it as it is. Known terms, you simplify. Whatever possible extent, you simplify. You can simplify like this. P pi by 4, 0.97 root of 2 into 9.81 into 0.89 into 9.81. So what is left out? Whole multiplied with left out is n d square root of h into h. So what is p? This term you can tell. You can simplify this entire term, tell some value. So that p we will get in n d square h to the power of 3 by 2. So this is not only the one procedure you to solve. You can solve in any method, as this problem is like open question. So what is the answer you'll get? Pi by 4, 0.97 root of 2 into 9.81 into 9.81 into 0.89. Okay, I'll write the answer. Okay, 29.46 n d square h to the power of 3 by 2. We will get in kilowatts. Keep it as it is. Next, we'll go for next. So I'm telling you can solve in any method. This is one procedure I'm solving. N is equal to what is the formula for u? U is equal to pi t n by 60, right? So u I can write as speed ratio into root of 2gh, that is equal to n pi d n by 60. What is known and what is unknown here? We'll take out n in this outside. N is equal to speed ratio is known for us. So I'll write the formula first. Root of 2g into root of h divided by pi into.
Sir.
Yeah.
Sir, I got the answer, but what is the m value, sir? In the question you have mentioned.
M is equal to capital D by small d.
Okay, sir. In the question, it's written wheel phi to jet phi. That's why I was confused, sir.
Wheel phi means it is wheel diameter. Sorry, that is income. Wheel diameter to the jet diameter.
Yes, sir. I got the answer, sir.
Did you got the answer? Can you project your screen? I'll stop sharing.
Just a second, sir.
Because no, this is in this for this problem. This is not only the one method to solve. You can solve in any method. But finally, we want this equation. We will get that. We can get no issue. There are so many methods to solve because you are substituting one in terms of others. You can easily get. One possible way is this. Can you project?
Yes, sir. Just a second.
Okay. If yes, I'll stop sharing.
I've switched on my camera, sir.
Shall I project now? Shall I switch off now?
Yes, sir. I can see my answer that one.
Just a minute. Yeah, now you start presenting. You switched on the camera.
Yes, sir. Because if I present, I'll be showing my phone right now. I did it in my notebook now. That's why.
Okay, okay. Can you all see?
I found out
Yes,
was
sir.
first. I found out the
See, what
B
you do
values.
is, you do one thing. What you do is, you take the photo of this. Save in
Okay, yes,
Excel, then present. It will be easy. See, others also, meanwhile, you please keep on trying to get the solution. Do you got?
I've started presenting, sir. Can you see me?
Huh? No,
I've
no,
started presenting.
no, we cannot see. Okay. Anyhow, what you do is you try to show that, you try to post that solution in a group, okay? So that others also will come to.
Okay, sir.
Okay, fine. Thank you. In the next class, we'll start the Francis turbine. That is next chapter. Bye. Thank you.